So we're going to go through the questions on radioactive decay. So the idea with these is to just figure out whether or not you have alpha, beta or gamma decay. And this is a great way here to, something that you might like to put in your notes of knowing what type of decay you're going to have. If you're going to have beta plus emission, or we'd call positron emission, that's when we have too many protons in the nucleus of the atom. If we have too many neutrons, we're going to have beta minus emission. If the nucleus is too big, often you'll have alpha emission, and if you have an overexcited element, then you're going to have gamma emission. And remember, the way that we'd show something that's overexcited, you know, I don't know, maybe like, you could even just do it with this, with radon, is you might have radon 218, 86, and we just show that it's excited, and this is for gamma radiation. And then we show that that actually goes back to radon. We don't change the atomic number or the mass number, but we then have energy, and that energy is a photon of energy or a gamma ray. So that's for gamma radiation, that particular one. There's actually no examples here of gamma. So if we do question 1, we've got determine the nature of the unknown X for the following transmutation. A transmutation is a change in the character of the atom, which results from a change in the nucleus. So if we look here, we've got 218 and 214. So you can see here, to go from one to the other, we know that we're going to have the balancing of the mass numbers and the atomic numbers. So what I do to do these is I actually write down what I've been given, polonium, and I look first across the top. Now I know I need to have the right side equal to 218, so that means I have 4 left to make that happen, and I have 2 to make 84 plus 2 is 86. So now that I know that I actually already know what X is. X is 4, 2, it's the atomic number 2, that's helium. So this is actually a helium atom, which remember is what we call an alpha particle. So that means that the degradation here, or transmutation in this radioactive decay, would be alpha type radiation, and we're emitting an alpha particle plus energy. So we actually should always add plus energy to these radiation questions too. This one's asking what type of beta decay occurs in the nuclear reaction. So I do the same thing again, 21482 lead goes to 21483 bismuth plus something. Now I know that here the top hasn't changed, because we've got 214 and 214, so there's a 0 over here. I've then got 82. Now to get that to 83, I must have a negative 1, because if we do 83 take away 1, we get 82. So what do I know that has a 0 and a negative 1? Well, that has to be an electron, and so 0 mass, but a charge of negative 1. And we know here that an electron is also known as a beta minus particle, plus this is also where we have the neutrino, or the antineutrino, which is our energy and mass equivalent. So if you've done that lesson on radioactive decay, you'd know that you have that there. Question 3 says what type of decay occurs when a nucleus has too many protons? That would be beta plus emission from our notes over here. What's a positron? Well, a positron is exactly the same as a electron, but it has a positive charge. So it has the same qualities as an electron. So that's in terms of its size and its speed. But it has a charge of +1. What is the nature or identity of alpha, beta and gamma radiation? Well, first of all, we know that, and I'll just put question 5 over here so we have a bit of room. We know that alpha radiation is a helium nucleus that's ejected. We know that beta plus is a positron that's ejected, positron, and all of these are ejected plus energy, as well. And beta minus is an electron that's ejected plus energy. Okay, cool. So they're the things that are ejected. Oh, and the last one is gamma ray. That's a photon of energy, pure energy that's released. And basically with the gamma radiation, essentially what's happening is you've got a restructuring of the nucleus. That's like, it's really disorganized, it's high energy, it loses that energy and goes down to a stable state. So that's where we release this photon of pure energy. So question 9, the last one, it says carbon-14 decays by beta minus emission to form the following. We can see the neutrino there. Oh, I should have put energy here as well. And we've got carbon-14 going to nitrogen-14, the equation here. It says, first of all, how many protons and neutrons does the nitrogen atom have? Well, protons, it's got 7 because we need to look at the atomic number down the bottom. And neutrons is always the mass number minus the atomic number. So in this case, you can see it would be, and the atomic number is at the bottom, mass number is at the top, it would be 7 neutrons. What particle on the left side of the equation is transformed into what particles on the right? Now, because we know here that we've got beta minus decay and we've got a neutrino, we know a little bit about what type of decay this is. On the left side of the equation, we've got carbon. Now, carbon has a mass number of 14, so that's 7, and an atomic number of 6. So that's 6 protons, and for a mass number of 14, it has to be 8 neutrons, because 8 plus 6 is 14. And on this side, we've got 7 protons and we've got 7 neutrons, which we worked out in the previous question. Now, because we had 8 neutrons and now 7 neutrons, that means that we lost a neutron. That means a neutron from this side has been lost, but it's turned into a proton, because you can see that you have one more proton. It's beta minus decay, so you also have one electron, which remember is the beta minus particle. And we also have the little neutrino, which is the little massless particle that accounts for energy. So we've ended up with these two things, and the reason why is because we know the charge on a neutron is a 0 charge. On a proton and an electron, it's a plus and a minus. Because we have one of each, those two are charge balanced then with 0 because they cancel each other out. So for this decay, you've had a neutron which has turned into a proton and an electron.